Have you ever hit run on a Java app and just had faith that it'll work? Well, today we're going to pull back the curtain on the Java virtual machine. We're going to look at the incredible high-speed assembly line that brings your code to life, way before your main method even gets a chance to run. So let's dive in.
So what is going on in that tiny moment between you clicking run and your program actually starting? You'd probably guess the JVM just grabs every single class file you wrote and crams it into memory all at once. But nope, it's way smarter than that. See, the JVM is efficient. It absolutely hates wasting time or memory on things it might not even need. So instead of a mad dash, it uses a perfectly organized, on-demand process. Think of it like a finely tuned assembly line for your code.
And the secret sauce to this whole operation, the thing that makes this assembly line so darn efficient, it all comes down to one word: laziness. And trust me, this is the best kind of lazy you'll ever see.
This is the core idea right here: lazy loading. The JVM simply will not load a class from your disk until it's absolutely, positively needed. So if there's a part of your code that never gets called, the classes it uses might never even see the light of day inside the JVM. This whole on-demand thing saves a ton of time at startup and keeps your memory usage down.
Okay, so if the JVM is being lazy, then who's actually in charge of this whole process? Well, that's where the gatekeepers come in, the class loaders. They're set up in a really strict hierarchy, like a chain of command, and it's their job to find and bring the right code into the JVM at just the right time.
At the very bottom, you've got the application class loader. That's the one that loads your code from your project's class path. One step up is the extension class loader, which handles Java extensions. And at the very top, the big boss is the Bootstrap class loader. It's actually built into the JVM itself, and its job is to load the absolute core Java API classes.
And these guys follow one simple but absolutely critical rule. First, ask your parent. This is called the parent delegation model. So when the application loader gets a request for a class, it doesn't immediately look for it. No, first it passes that request up to its parent, the extension loader. And the extension loader does the exact same thing, passing it all the way up to Bootstrap. It's only if nobody up the chain can find the class that the original loader is allowed to try. And this is so important because it prevents you from, say, accidentally replacing a supercritical class like java.lang.string with your own version. That would be a total disaster.
And this table really lays it out. The Bootstrap loader is for the absolute fundamentals, from Java's core library. The extension loader handles any optional packages. And the application loader, well, that's your domain. That's where your code lives. Each one has its own turf, which keeps the whole environment stable and secure.
Right. So, the class loaders are the gatekeepers that find the file. But what happens after they find it? Well, that file gets sent down a mandatory 3-phase assembly line before it can be used, and each station on this line has a super important job.
Every single class that enters the JVM has to go through these 3 stages, in this exact order: loading, then linking, and finally initialization. Let's start at the beginning of the line, the loading phase.
This is step 1. The class loader finds the .class file on your disk, reads all of that raw binary data, the bytecode, and then uses that info to create a special class object right inside the JVM's heap memory. So now, the class is technically inside the JVM, but trust me, it's not even close to being ready for action.
Next, it moves on to the linking phase. This is kind of like the quality control and setup station. Linking itself actually has 3 little substeps. First is verification. This is a huge security check to make sure the bytecode is legit and isn't going to crash the JVM. Think of it like a security scan. Next is preparation. Here, the JVM sets aside memory for any static variables in the class and just gives them a default value, like 0 or null for now. And finally, there's resolution. This is where the JVM connects all the dots. It finds all the symbolic names in your code, like class names or method names, and swaps them out with the actual direct memory addresses. After all that checking and setting up, the class is almost ready. It just needs to be powered on. And that's exactly what the initialization phase does. This is the moment when those static variables finally get the real values you assign them in your code. And even more importantly, any static code blocks you wrote inside the class, they get executed right now. The key thing to remember is this whole phase happens only once per class, and it only happens right before that class is used for the very first time.
Okay, I know that was a lot of theory, so let's make this totally clear and actually watch this whole process unfold with a super simple piece of code.
So here's our class. We'll call it test. It doesn't have any methods or variables, but it has one very special thing, a static block. And remember, the code inside a static block is what gets run during that initialization phase.
Now, how do we force this class to load? We can use this one line of code, class.forName test. This is basically a direct order to the JVM. It says, hey, go find the class named test, and I want you to push it all the way through loading, linking, and initialization right now.
So when that trigger forces the initialization phase to happen, the JVM has to execute the code we put inside that static block.
And boom, there's our result. The class.forName call kicked off the entire three-phase process. And as soon as it hit initialization, our static block ran and printed that message to the console. We literally just watched a class go on its entire journey from file to fully initialized object.
So what this all really boils down to is that nothing in the JVM just happens by chance. It's not some magic black box. It's an incredibly well-structured system that's designed from the ground up for security, efficiency, and stability.
So let's recap one last time. The loading phase gets the code in the door. The linking phase makes sure it's safe and get its memory ready. And the initialization phase flips the power switch, running static code and assigning its final values. Loading, linking, initialization. That's the journey every single Java class takes.
And that leads to a final thought for you. Now that you get it, now that you understand lazy loading and the fact that initialization has a cost, how could this change the way you write your code? How could you use this knowledge to build an application that starts up way faster just by putting off some of that heavy initialization work until it's actually needed? Some that chew on. Thanks for tuning in.